Good morning. Welcome to the lecture series of object-oriented programming concepts in Python. In the previous class, we discussed about the function overloading. In today's class, we try to discuss about the operator overloading. The Python programming language supports the operator overloading for the following operators. One is the arithmetic operators, assignment operators, relational operators, unary operators, bitwise operators. First, we try to discuss about the arithmetic operators. The Python programming language itself supports the overloading for the addition operator. We take the example print 2 plus 3. So automatically we are passing the arguments or the integer variables 2 and 3, and we want to perform the addition operation, then automatically displays the output as the 5. And next we simply pass we use the another example Hemanta plus Kumar. Here we are passing the two parameters are the strings, and we want to perform the operation is plus, but here it simply performs the string concatenation. So automatically we are using the same operator plus. If you are passing the numerical values, either it may be the integers or the real numbers, it simply performs the mathematical addition. Or if you pass the strings as a parameters, it simply performs the string concatenation. Now we try to take the another example 1, 2, 3 plus 4, 5, 6. Here the first 1, 2, 3 is representing as a list consisting of the 3 values. Another one is the 4, 5, 6 is also be a list, and we want to apply the plus operator between the two lists. Automatically it simply performs the list concatenation. Then automatically the result is simply consisting of the 1, 2, 3, 4, 5, 6. So in this example we understand that the plus operator works based on the operands we are using. We are passing the numerical values, it simply performs the numerical addition. Example is the 2 plus 3, we get the values of 5. Or we pass the string Hemanta and Kumar, it simply performs the string concatenation. And we pass the list, then automatically it performs the list concatenation, that is the two lists are added. So in that way it simply performs the plus operator. So automatically we understand that the plus operator works differently based on the parameter we are passing. So it simply supports the polymorphism. And the next one is we try to define a class complex. Already we know that complex variable, every complex value is consisting of the two values, one is real and another one is the imaginary. For that reason, here we simply define the constructor of the complex. It takes the real and imaginary as the parameters, and we assign the real value to the self.real and image is assigned to the self.image. That itself indicates that for every complex object is consisting of the real and imaginary as the object data members, and what are the parameters we passed. The first parameter is assigned to the real value and the second parameter is assigned to the imaginary value. And next we simply define the str function. Its main purpose is whenever we need to use the print the object of the complex class, we simply display the real value plus imaginary value followed by the I symbol. That is nothing but we want to display what is the values existing on the real attribute, and plus symbol need to be displayed followed by the imaginary value followed by the I symbol, that is we want to display. For example, here we try to discuss a is equal to complex of 10, 20. Now a is an object of the complex class and the a real value is consisting the 10 and a object imaginary value consisting the 20. Now we try to define the b is another complex object and passed parameters are the 20 and 30. That itself indicates that b object real value is 20 and b object imaginary attribute value is the 30. Now we try to display the print of a. So automatically it displays the value is the 10 plus 20 because a is a complex class object, its real value is 10, for that reason it displays the 10 and the imaginary value is 20. So it simply displays as the output as the 10 plus 20i. Similarly, we simply call the print b, automatically it displays the output is the 20 plus 30i. Now we try to use c is equal to a plus b. So what is the expected value of c? Here we are passing the using the plus operator, and the two objects are the complex objects, and our intention is we need to perform the addition of the two complex objects. That is, we are expecting the result is the 30 plus 58 because the real value is some 10 plus 20 30. The imaginary value sum is the 20 plus 30 is the 50. So we are expecting C object real value is 30 and imaginary value is the 50. but it actually gives an error message. Why it gives the error message? We try to apply the addition operation, plus operation on the objects is the A and B are the complex. That addition operation is not different. That is, it simply specifies that unsupported operand types complex. That is, the plus operator is able to apply either the numerical values, either it may be the real numbers or the integer values, or we can apply on the list, or we can apply on the string. But the complex is a user defined class, and the operator is not defined to perform that work. So whenever we need to perform the addition operation on the complex objects, we need to overload the addition operation on the complex. So in the Python programming language support the operator overloading. So here these are the methods are different. Whenever we need to overload the plus operator, we are using the underscore add underscore. You need to pass the two parameters, self and what is the other object we need to perform the addition operation. Similarly, subtraction purpose we are using the SUB, multiplication purpose we are using the MUL, and similarly the division purpose we are using the true DAV, that is nothing but it is performing the integer division. Example is the 5 by 2 we get the value is 2, or the 9 by 2 we get the value is equal to 4. So those are the true division. And next one is the floor division, that is nothing but the floating point value. For example, 5 by 2 we get the value is the 2.5, 9 by 2 we get the value is equal to 4.5. And similarly the modulus operation mod, and similarly the power double star we are using the POW. It is used, for example, 2 double star 3, it gives the 2 cube is equal to 8. So for these operators we are able to methods is these are the add for addition, plus operator, SUB for subtraction, MUL for multiplication, true div for the integer division, floor div for the floating point division, mod for the modulus operator, POW for the power operation. Now we try to discuss with an example how to perform the addition, that is how to overload the plus operator to perform the complex number addition. So here already we defined the complex is a class and it is having the constructor, it takes the real and imaginary, those are assigned to the real and imaginary objects, and we define the str function to display purpose. And next we are using the def underscore add, def underscore add underscore. It is nothing but we try to overload the addition operation. Here it takes the two parameters, one is the self and another one is the other. So to store the result, for that purpose we are creating a temporary complex object, that is nothing but C is equal to complex of 0, 0. That is nothing but we are C is one of the complex object, its real value is 0 and imaginary value is 0. Now we are assigning C dot real is equal to self dot real plus other dot real. That is nothing but what is the other object real value that is added to the current self object real value. The result is assigned to the C dot real, and similarly self dot image plus other dot image is assigned to the C dot imaginary value under return C. That is, we try to define a function underscore add underscore. It takes the self comma other and it simply calculates the summation of the two complex objects, that is the real values sum is assigned to the C dot real and imaginary value sum is assigned to the C dot imaginary, and we simply return the C object. So this is the way we are able to overload the plus operator. Now we try to discuss an example. Here we are using the A is equal to complex of 2, 3. Now A is a complex object, that A object consists in the real value is 2 and imaginary value is 3. The second statement we are using as the B is equal to complex of 4, 5. Now B is a complex class object and the B dot real is having the 4 and B dot imaginary is having the 5. Now we try to use the next statement, print A, it simply displays that the 2 plus 3i, and print B, it simply displays the 4 plus 5i. Now we use the C is equal to A plus B. In the previously we used the C is equal to A plus B, we get the error because at that time the plus operator, we are not, operator overloading is not defined. But now we defined the operator overloading plus operator on the complex objects. In the previous slide we discussed how to define underscore add underscore. It takes the two parameters self comma other and it performs the addition of the real values and imaginary values, the result is returned. Now we take the C is equal to A plus B, then automatically here in this one self is representing A, other is representing B, and their real values sum is assigned to the C dot real and A and B imaginary values sum is assigned to the C dot imaginary. Now we try to use the print C. automatically the output is displayed as 6 plus 80. Why you get the 6? Because A dot real is having the 2 and B dot real is having the 4. Their sum is equal to 6. Similarly, A dot imaginary is having the 3 and B dot imaginary is having 5. Their sum is equal to the 8. In that way, we are able to get the C object real value is 6 and C object imaginary value is the 8. I hope you clearly understand how to overload the plus operator for the complex class and how we are able to use the overloaded operator. This is one of the simple example to perform the operator overloading for the addition operation. Similarly, we are able to define the subtraction operation. Minus, we are using the SUB. Similarly, the star purpose we are using the MUL. Similarly, for the integer division purpose we are using the true div, and similarly the floating point division purpose we are using the floor div, and similarly to calculate the modulation operation purpose we are using the mod, and similarly for the power function we are using the POW. So these are the how to overload using these method names. I hope you clearly understand the arithmetic operator overloading. And the next type of operators is the assignment operators. So automatically in the Python programming language support the overloading for these operators. The first one is the plus is equal to A plus is equal to B. That is nothing but whatever the values existing on A, B values also be added to A and the result is assigned to A. So for example, already we are assuming that A is a complex object and B is a complex object. Their sum need to be assigned to the A. Whenever we need to define, then automatically it is possible to define using the IADD. That is nothing but previously add is used for the plus operator, and IADD is nothing but whenever we need to overload the plus is equal to operator, we are using the IADD. Similarly, the other operators is the minus is equal to for I sub, star is equal to I multiplication, division is equal to I div, and next one is the double slash div is the I floor div, and similarly the mod is equal to the I mod, and similarly the double star is equal to I POW. These are the methods. We take one simple example. Already we know that the complex class and its constructor and the str function. Now we try to define the IADD of self comma other. So already we know that IADD is used to overload the plus is equal to operator. For that reason we are using the IADD and we take the two parameters is the self comma other. Then automatically here also we take the C is a complex class object. Initially its values real and imaginary is 0. And next we take the C dot real is equal to self dot real plus other dot real, and C dot imaginary is nothing but the self dot imaginary plus other dot imaginary, and simply returns the C. Now we take one simple example. A is equal to complex of 2 comma 3, B is equal to complex of 4 comma 5. These two are the A is a complex object and B is a complex object. Now we are using the print A, it simply displays the 2 plus 3i, and print B, it displays the 4 plus 5i. And next we use the statement A plus is equal to B. That is, we are overloaded the plus is equal to operator. Now we try overloaded for the complex objects plus is equal to, and we applied the operation. So automatically A dot real is nothing but the A dot real plus B dot real. Similarly, A dot imaginary is nothing but A dot imaginary plus B dot imaginary. Now we try to print the value of A. It simply displays the 6 plus 8i. So I hope you understand how to overload the plus is equal to operator. Similarly, the remaining operators also we are able to apply. Minus is equal to, and similarly the star is equal to, double star is equal to, we are able to overload. The Python programming language is also supports to overload the relational operators. Already we know that the relational operators is less than or equal to, not is equal to, greater than or equal to, greater than. Now we try to, these are the methods we need to use. For the less than purpose we are using the LT. For less than or equal to purpose we are using the LE, and equal to purpose we are using the EQ. Not equal to purpose we are using the NE, and greater than or equal to purpose GE, and similarly the greater than purpose we are using the GT. Now we try to take one example for the operator overloading for the relational operators. For the example purpose, we take the rectangle class. Already we know that for every rectangle is having the two attributes. One is the width and another one is the length. So we define a rectangle class. With the constructor, it takes the width and height. Those are assigned to the object data members of the width and height. And similarly, we define the greater than function. So here the def underscore underscore gt underscore, and so that itself indicates that we want to overload the greater than function, and it takes the self comma other, that is Whenever we need to use the A greater than B, A and B must be the rectangle class objects, then this code will be executed. First we need to calculate the area of the first operand, that is nothing but the self. Already we know that how to calculate the area of the rectangle, width into height. For that reason we use the first statement is area 1 is equal to self dot width into self dot height. And second operand, that is nothing but the other. To calculate the area we are using the statement is the area 2 is equal to other dot width into other dot height. So automatically area 1 is representing the first operand area, area 2 is representing the second operand area. Now we simply use the statement is the return area 1 greater than area 2. So that is nothing but if the first operand is area is greater than the second operand, then it returns true, otherwise it returns the false value is written. Now we try to discuss with an example how we are able to use the greater than symbol for the rectangle objects. First we created the two objects, R1 is equal to a rectangle of 4, 5. So R1 is one of the rectangle class object and R1 dot width value is 4 and R1 dot height value is 5. Similarly we created the R2 object. The R2 object width value is 3 and R2 object height value is 7. Now we try to use the statement if R1 greater than R2, print R1 is greater than R2, else print R2 is greater than R1. In this example, R1 area is 4 into 5, 20. R2 area is 3 into 7, 21. Already we know that 20 greater than 21, it is a false. For that reason, it simply displays the R2 is greater than R1. So the output we obtained is the R2 is greater than R1. So I hope you understand how to overload the greater than, that is nothing but the GT method. So we simply define the GT method with the two parameters self comma other. Self is representing, this example self is representing R1, other is representing that. That is the first operand is representing the self, second operand is representing the other. Similarly, if you want to overload the other parameters, either it may be the greater, less than, we are using the LT, equal, we use the EQ, or not equal, we use the NA. In that way, we are able to overload the other relational operators. So other type of operators are also supported. Overloading is the unary operators. The Python programming language is also supports for the unary addition. Example is the A is equal to plus B. So the positive value of A is simply as it. So whenever we need to use POS is the method name, and similarly the negation. Example is the B is equal to minus A. Already A value is equal to 7. B is equal to minus 7 we are able to get, or we are assuming that B is a complex, A is a complex variable, real value is 3 and imaginary value is 5, and we need to define B is equal to minus A, we need to get real value is equal to minus 3 and imaginary value is equal to minus 5. That is the values we need to negative operation we need to apply, then we use the NEG method to overload. And similarly the ABS, so absolute value, for example we pass a parameter is a positive, we get the positive only. If we pass a negative, it is also converted to the positive. So it is possible to overload the unary operators. For plus we are using the POS, minus we are using the NEG, and similarly the ABS we are able to use the ABS. And similarly the for invert operation we need to apply the inversion operation, we use the method name is the INVERT. So similarly the bitwise operators, it is possible to overload the bitwise operators of the shift left. For that one we are using the IS shift, similarly the shift right, RS shift, and similarly the bitwise AND operator we use the and similarly the bitwise exclusive OR operator XOR, and bitwise OR operator we are using the OR. In that way we are able to overload the bitwise operators. I hope you understand how to overload the operators in the Python programming language. We discussed about the arithmetic operators with example, and similarly the relational operators and assignment operators, and similarly we also discussed about the unary operators and bitwise operators. So the Python programming language supports the operative overloading for all these arithmetic operators, relational operators, unary operators, assignment operators, and unit operators. Thank you for listening.